Okay, so from the trig review, just so you know, any of these formulas here, the SOHCAHTOA formulas, you can treat those as basic algebraic formulas. So here, if you're looking for the adjacent side of the angle, so if I'm looking for this x here, if you didn't know these red values, you could say, well, the tangent of theta is opposite over adjacent. But we don't know the adjacent, so you could say the tangent of the angle equals the opposite side, which is 10, over a, but then you solve for the a, so the a goes up to the other side and the tan 42 goes down. And then you just solve that and your a will come out to 11.2. And I've done that over here as well. Sine theta equals O over h. But if you want to solve for O, you just multiply the h up here, and the O can stay there because it's already on top. And so you have h times sine of theta, and you plug those numbers in and you get the 232 here. So you can do that in lots of different ways, but you can move those formulas around. Okay, here's an example. Can I erase this now?
How did you go from the sides to the angles in the first example?
Here?
Did you use like arctan or something?
Yes, so in order to get these angles, that was the first thing that I did. So if you look at theta, you have opposite and hypotenuse, right? So the arc sine, or the inverse sine actually, of opposite over hypotenuse is equal to theta, right? So if you do shift sine on your calculator, put in 10 divided by 15, that should give you, I think it was 41.8.
Yeah.
Okay. Let's do a little example. We went outside there and some of you tried to walk and then your friend made you push each other. I'm sorry about that. Hopefully it was nice. But you pushed that perpendicular, and what happened to your motion? We went kind of diagonally, right? You try to walk straight, but if someone's pushing you, you end up kind of strafing over. Okay, give me a celebrity. Billie Eilish. Okay.
Michael Jackson.
I like Billie Eilish. Okay, so this is the river problem. So put this title in your notes. It's a good place to start our 2D kinematics. We're going to have a river, and that river is there's little waves in the river, and there's a fish somewhere. And how wide is this river?
20 meters.
20 meters, I will take that. Okay, so this is 20 meters across. And Billie Eilish is standing here. Now, what would Billie Eilish swim across a river for? Food?
A bad one.
A bad one. What does she like to eat, do you think?
Tacos.
Tacos, yes, I love it. Okay, so we're gonna have a taco over here. Let's see if I can draw a taco. And there's all this stuff in the taco, right? Okay, there's a taco on the other side. And Billie Eilish wants to swim to the taco. How fast can Billie Eilish swim? 2 meters per second? Okay, let's say that she can swim at 2 meters per second. The trouble is the river is flowing. Okay. Actually, I'm gonna make Billie Eilish is a pretty good swimmer, right?
30 meters per second.
Let's say 20. Let's say 20. She can swim at 20 meters per second, but the river is flowing. And we'll say that this is north, south, east, west. We'll say up on the board is north, and left is west, and east is to the right. Okay, so she wants to swim north to her taco, but the river is flowing to the east, give me a number less than 20.
15. 19.999.
No, 18, 6,
15.
14, 10.
Let's say 14. 14 meters per second, okay? Now, Billy is going to try to swim straight for the taco. So she's going to swim straight across. But being smart, she knows that she's going to be pushed in what direction?
Right.
She's being pushed east, right? So is she going to end up at the taco?
No.
If she started here and swam straight up, what would happen? She would actually end up moving diagonally, right? She would end up down here. So she's going to walk back on the shore. She's a very good physicist, Billie Eilish. And so your job is to tell Billie Eilish how far does she have to be. So she's not going to start here. She's going to start upstream. And how far upstream does she have to start so that when she gets to the other side, she's going to swim straight across. She's going to swim straight across at 20 meters per second. But the river is going to push her east. How far from the taco spot does she have to start so that she ends up right at the taco? That's question number 1. Discuss it. Try to find out how to do this.
Why can't she just swim diagonally left?
Oh, she can, but it'll take her too long. She wants to get to the taco in the minimum amount of time. That's actually the next question. Discuss how to do this. How are you going to solve for that? You know what? I made this really easy for you, actually.
Yeah, it's a bit.
I made it way too easy.
Yeah, let's discuss it for a second.
Okay.
I haven't heard the right answer yet, but
I said
you did. Should I make it harder?
No.
Yes.
No.
Okay.
No.
So question 1
how does one
is how far upstream?
1 second figure that out? Like, and she's trying to like, you're seeing both
Need to start in order to hit the taco.
Or she can just swim, hit somewhere, and walk towards the tackles.
Here's a question. In order to solve for this, do I need to do trig? No, you actually don't have to. No trig needed. No trig needed. This question is a really good example of what you're learning today. And what you're learning today is the independence of perpendicular vectors. Say that with me.
The independence of perpendicular vectors.
Good. What does that mean? What does perpendicular mean? Show me with your hands. This is parallel, right? What's perpendicular? Like this, right? At right angles, that's perpendicular. What does independence mean?
By yourself.
You're gaining your independence right now, right? Human being. Perpendicular vectors can be thought of as independent things. Okay, so I'm going to give you a little hint. Some of you have got this already. And I made the numbers way too easy, so I'm sorry about that. But step 1 to solve this problem is to find out how long it will take. You want to find the time it's going to take her to get across. And this is an interesting thing. So if there was no river current and she was just swimming at 20 meters per second straight across the river, how long would it take her to get across?
1 second.
Good, 1 second. Now, if you do that mathematically, the formula would be T equals D over V, yes? Okay, so my distance is 20 divided by my velocity of 20 meters per second. We should get 1 second, right? This kind of makes intuitive sense. Yeah. So T is equal to D over V, and this comes from V equals D over T, right? If you rearrange that, you get D over V. And so for our example, T is 20 meters over 20 meters per second, and that's going to equal 1 second. It's going to take her 1 second across. Now, if you speed up the river, and she's really pushed hard sideways, then how long is it going to? Is it going to take her more time or less time?
More.
The route left me the same.
Brigitte, say it again.
At the same time, because she's still going at the same speed.
Golf clap for Brigitte. It's the same time.
It's like the falling thing.
The reason is because perpendicular vectors are
Independent.
independent.
It's like when you throw something, it doesn't matter. We already did this. It doesn't matter the speed it's going, it's gonna follow the same.
Exactly. If I throw this thing to I've blanked Dylan. If I throw this to Dylan's been a long spring break. If I throw this to him, good catch, it's gonna be constant horizontal velocity. It doesn't matter what gravity is doing to it. You can throw that back to me now. It doesn't matter what gravity is doing to it. The horizontal velocity is unchanged because gravity is perpendicular to that. So perpendicular vectors are totally independent of each other. Show me the direction of this 20 meters with your arm. It's this way, right? And in which direction is she swimming 20 meters per second? This direction, right? So those two things are dependent on each other. Our 20 divided by 20 is all in the same direction. It doesn't matter what the river does because it's perpendicular. The river could be going 1,000 kilometers an hour. It doesn't matter. It would still take her 1 second to get across. Now, she would she be at the taco?
No.
No. So she's going to need to start up here, right? Because otherwise she's going to swim and she's going to get it pushed downstream. But we know how long it's going to take her to get across. It's just going to take her 1 second. So if the river is pushing Billy at 14 meters per second east, how far will it push her in 1 second? 14 meters. So how far upstream must she start? 14 meters. So this x has to be 14 meters. I made this too simple because the 20 meters. You try. Tell us. Mila, tell us.
Why should, if it's gonna take her 1 second to cross?
Yes?
Oh, then.
The river's pushing in what direction?
East.
Right, east. And what's the velocity of the river?
14 meters per second.
Good, so if the river's pushing 14 meters per second for 1 second, how far will it push her in that time? 14 meters, right? And the mathematical way to do that, and this is step 2 of the problem. And of course, it's not gonna always be this easy, right? I don't know why I did that 20 and 20. I shouldn't have done that, but step 2 is to find dx. So I would call this 20 meters, I would call dy, because it's 20 meters north. And you want to find out dx. And so you would use the same formula. There's no acceleration going on here. This is constant velocity. But we want to find d, and so d is equal to v times t. And I'll say dx and vx. And so that's equal to 14 meters per second times our 1 second is going to be 14 meters. Okay, Okay, so she has to start 14 meters back, and then the river can push her 14 meters and she'll hit her taco.
What is the
I'm just thinking X direction and Y direction. So it's just how far she'll end this. Now, let me ask you a question. Billie Eilish swims at 20 meters per second, right? And the river is pushing her sideways. Is the river speeding her up or slowing her down? Or neither? Yeah, she's swimming at 20, right? But the river's pushing her sideways at 14. Is the river speeding her up, slowing her down, or neither?
Until she reaches 14 meters per second, speed up.
Ty.
Overall, when you add both of those speeds together, she's speeding up.
Good. Golf clap for Ty. If we were to look,
that's what you meant.
if we were to look from the shore or from a helicopter over top, what you would see is that she's swimming at 20, but the river is pushing her at 14, and so her resultant velocity is going to be bigger than either of those. Right? Do it quickly right now. Find out her actual velocity. 24.4? So you just do Pythagoras. Now, I don't understand. If she's going 24, how come she still gets across in 1 second? Isn't she going faster? Shouldn't she get across in less time?
Distance is more than 24.
Ah.
More than 20.
So if you were to measure the displacement in this direction, it wouldn't be 20, would it? It would be 24.4, because the river is 20 meters wide. She drifts 14 meters to the side, and so her actual total displacement is this. Maybe it was a good thing I gave you the easy numbers. Does that make sense? Kind of, sort of? Okay, okay. Can they see these questions from the video?
I don't think it's fair. No, I don't think so.
I'm just gonna move this. If you're watching the question and you haven't seen this, you can see it now. So if you want to add together two perpendicular vectors, you can do it this way. Well, actually, we didn't even add the vectors. You can treat the vertical vectors as independent from the horizontal vectors. Okay, independent things, separate situations. Now I'm going to give you another little bit of a question. And I'm going to say, okay, Billy, it turns out, would rather swim than walk upstream. Okay? This is the second question. Billy's done the calculation. She's like, 14 meters is a long way, so I don't want to walk up there. She's going to start straight across. So this is not going to happen anymore. Okay? She's like, nope, I don't want to do it. I'm not doing it. I'm just going to get in and swim. Is there a direction that Billy can swim and still hit the taco on the other side? Okay, so if she swims that way, what's going to happen? The river's pushing her, so she's going to be even further down here, right? That's not helping us. If she swims against the river at some angle, will she be able to end up moving straight across?
Yes.
Yeah. Will it take the same amount of time? Longer or shorter? It's gonna take a longer time, right? But there should be an angle that she can swim at 20 meters per second with the river pushing her at 14, where she ends up, her actual movement relative to us sitting on the bank watching is straight up, and she will end up reaching her taco. Okay, so the question is, at what angle? We'll call it theta. So if Billy starts directly across from the taco, at what angle does she have to point herself so that she will swim? It's kind of weird to look, but this actually happens in real life. If she swims at this angle, she will move. It'll be slower, but she will move towards the taco. Okay? So if Billy, don't yell it out.
What?
If Billy starts directly across from the taco, what angle theta must she swim at to move directly towards?
Oh, yeah. Yeah, I got it.
This is A, and B is, how long does this take? So I've kind of done the physics for you a little bit. I've drawn you the vectors. And this is a thing, when you add vectors, you draw them tip to tail. So we start off with Billy swimming in some direction. We don't know the angle yet. But then we draw the vector of the river from the tip of that vector to the tail of it, going this way. And then you go from where you start to where you finish, and that's your resultant vector. Now we want this to be straight up. So this is going to be a right triangle. And we just need to know this angle here. Which trig function will you use? You could use sine, or can you use sine? Yeah, you can use sine.
Yeah, because opposite. I would just do the.
I think that's the only one you can use, actually.
Yeah.
So if you do inverse sine of 14 over 20, you should get, is it 44?
44.4.
44.4.
4 times 20. Yeah, 44.4.
So our theta ends up being 44.4 degrees. I don't understand. How come she's pointing herself this way, but she ends up moving straight across? How does that happen?
Because the river's counteracting going.
So in this case, the river is kind of slowing her motion across the river. But if she went straight up, the river would push her sideways, right? So she has to fight the current a little bit. And then she will move across. A few summers ago, we went to Austria, and we were biking on this river, the Danube River. It's very beautiful. I highly recommend it. And in some places, there's a ferry, and the ferry crosses the river. And you ride on there on your bikes. But the ferry can't point itself straight across the river. Because if it does, what's going to happen? Then the river will push it downstream and it doesn't get where it needs to go. So when you get on the ferry boat will point itself into the current, and it moves slowly across the river in the same way that Billy's doing. So this really happens in real life. How are you going to find out how long it takes her? Iman.
What is the VR? Then
Good, so we want to find this velocity, right? because Iman's right. We know the displacement across the river is 20. So now we need to find out, well, how fast is she moving vertically? Is it going to be more than 20 or less?
More than
Oh, it's going to be less than 20, right? You could do this any number of ways. You could use a trig function, or you could use Pythagoras.
14.20.
Let's do Pythagoras. So let's do the square root of 20 squared minus 14 squared.
It's gonna be 14, right?
14.3?
Yeah.
14. So she's only moving a little more than the river is moving. Okay, so now you have her vertical velocity. Because she's pointed diagonally now, her velocity, her swimming velocity is being kind of cut down by the river. So she's only moving across at speed. So now we do the 20 divided by 14. So we go t equals d over v, and this is going to be 20 meters. And I'll say dy and vy. And so the vy is 14.3. So this is like 1.6 or something?
1.4.
1.4 only? Are you sure?
Yes. Technically, since there's 1 second, it's 1 second.
Fair.
Nothing has changed.
Nothing's changed, it's the same thing. 1.4 it is. So it takes her a little longer to get across, right? But she can move straight across.
Okay.
It's like
Mila, go ahead.
I don't understand how you got 14.3.
I did it with Pythagoras.
Yeah, no, that's what I'm doing. I'm not getting that answer.
Okay, so let's do the math of it. I'm glad that you brought that
Oh,
up.
I know.
Okay, so Pythagoras says a squared plus b squared equals c squared, yes?
Yeah, so I'm like doing c squared
Yeah.
minus a squared.
Right, so let's say b squared equals c squared minus a squared.
Yeah.
So the 20 is the c, and this would be the a, right? So when we solve for b, you have to do the square root of c squared minus a squared. This might just be a calculator thing. If you do 20 squared minus 14 squared, you might have to put this all in brackets.
Right? 20s. Oh, I didn't do 20.
Yeah, this is 20. The c has to be the long side. Elena, you had something?
oh no, I was gonna say like if you for
Yeah.
time instead of using dy over vy, can you do dx over dx?
It doesn't really matter as long as you're using this velocity and this direction. They have to be in the same plane. Any other questions out there? Does this make
Once
sense?
you have VR, how do you find the time?
So T is d over v. As long as the displacement and the velocity are in the same direction, then you can just use this normal formula. So it takes her a little bit longer. Yeah,
She
don't.
has to walk this way, 14 meters, which takes. But she
Yeah.
can swim
So
20
you
meters
don't
per
know.
second.
I don't know which one is better. Like if she
Mr.
it's probably honestly it probably takes less time to walk the 14 and then just swim straight across.
She can
This is
swim
gonna
20
take her
meters per
longer.
second.
Yeah, she's a really fast swimmer. Like she's like she's gonna win every gold medal at the Olympics. Yeah, she almost could teleport. That's what?
She's got to switch careers.
Yeah, she really like the music career is good, but I think she needs to be able to become an Olympic swimmer. It might be better. By the way, if you fall out of a boat and you're in a river and you're in trouble, which direction do you swim?
Towards the sides.
Straight towards the shore.
Oh yeah.
Do you ever fight the current? No. Why not? Because that will mean it will take you longer to get to the edge, right? Say that again? Well, if you're at the edge, you're not in trouble, are you?